All right, let's jump right into this explainer. For the longest time, artificial intelligence was, well, it was something that lives safely inside a lab, right? It was this theoretical marvel running in these perfectly controlled, pristine sandboxes. But right now, we are witnessing a massive, honestly, kind of messy shift. These models are breaking out of the research phase and colliding head-on with the real world. So today, we're going to look at the invisible architecture that actually makes this survival possible. And more importantly, we're zeroing in on the completely new class of engineers being paid massive premiums to build it, the forward-deployed engineer.
To really grasp the stakes of this transition, just look at this single number, 275,000. According to job market data from mid-2026, that is the staggering number of unfilled AI roles just sitting open right now. I mean, the demand is absolutely explosive. It's outpacing basically any tech trend we've seen in the last decade. But, as you'll see, companies aren't just looking for any software engineer. They are hunting for a very, very specific type of builder.
And that brings us to a really fascinating paradox. If there are hundreds of thousands of open tech roles, why are generalist, mid-level engineers facing this brutal wave of layoffs? Meanwhile, you've got this highly specific class of AI experts commanding total compensation packages of $500,000. Like, what exactly is the disconnect here? Why is there such a massive gap between the engineers we have and the engineers the market so desperately wants?
Well, let's explore that in Section 1, the 2026 Tech Job Paradox. So, the AI hype cycle has finally matured, and the very first casualty, the novelty titles. The standalone prompt engineer role has effectively died. I mean, the skill itself survived, obviously, but it's now just basic table stakes. You're definitely not going to see it headlining a job board anymore. At the exact same time, traditional junior roles, basic front-end coders or QA engineers writing routine tests, they're being rapidly displaced. Why? Because AI agents can just execute those tasks faster and cheaper. The baseline for what makes an engineer valuable has literally shifted overnight.
We're basically living in a bifurcated reality right now. In just the first quarter of 2026, we saw over 52,000 generalist tech layoffs from major players. It's a freezing cold, unforgiving environment for generalists. But on the exact same timeline, AI roles grew uncontrollably, leaving those 275,000 open seats. So you have this icy market for mid-level generalists existing right alongside a boiling hot, totally chaotic seller's market for senior AI specialists. You're either a commodity or you are an absolute premium. There's almost no middle ground left.
So, who exactly are these highly sought-after specialists? Let's jump into Section 2. Enter the infrastructure engineer.
I absolutely love this quote from an AI infrastructure director because it perfectly captures the current bottleneck. They said, "We used to worry about algorithms, now we worry about clusters." Think about it. A trillion-parameter language model is incredibly smart, but it's essentially a giant brain trapped in a jar. It is completely 100% dependent on physical infrastructure to survive and communicate. The entire AI economy now runs on how efficiently we can move massive amounts of data through silicon. If the infrastructure fails, the intelligence literally dies. Now, the crucial point here is how fundamentally different this new infrastructure actually is. Traditional DevOps was entirely deterministic. It was like a reliable factory assembly line, right? You sent a request to a CPU, a hard-coded rule ran, and you got a predictable output. But AI systems, they are probabilistic. It's way more like rolling loaded dice. You aren't writing rules anymore. You're managing massive parallel GPU clusters trying to predict the next token. It's a massive shift from keeping a predictable web app online to managing this incredibly resource-hungry dynamic intelligence that just eats compute power by the second. The playbook has been completely rewritten.
Picture this. It's 2:13 a.m. An inference queue for a massive enterprise-grade AI coding assistant starts piling up. Somewhere, a pager buzzes. An AI infrastructure engineer logs on in the dark. Now, they aren't tweaking the AI's algorithm. They couldn't care less about the neural net in that moment. They are fighting a raging structural fire. A GPU cluster is out of memory, and every single minute of downtime is burning real money and halting productivity for tens of thousands of users. This engineer has to reroute and rebalance workloads to backup nodes in real time. They are part systems architect, part digital firefighter. The stakes are just incredibly high.
To fight those fires, you need specific gear. Let's look at Section 3, the AI Infra Toolkit.
Okay, first we need to clarify the taxonomy here because to an outsider, these titles sound exactly the same, but they are vastly different. A machine learning engineer is the architect. They design, train, and fine-tune the model itself. But the AI infrastructure engineer, they're the civil engineers and the city builders. They construct the robust, distributed systems, the deployment pipelines, and the orchestration that actually allows that brilliant model to serve 1 million users simultaneously without just collapsing under its own weight. Basically, the ML engineer builds the engine, the infra engineer builds the entire car around it.
Looking at the core toolkit for 2026, Python remains the absolute baseline. It's in over 70% of job postings. But it's what you build around it that matters. You need Kubernetes for container orchestration. You need a really deep, practical understanding of vector databases to power retrieval architectures. You need orchestration frameworks like LangChain. And increasingly, and this is a huge one, you need mastery of MCP, the Model Context Protocol. You need that to securely connect these isolated AI models to real-world, real-time enterprise data sources. Because without MCP, the AI is completely blind to what a company is actually doing today.
And as this infrastructure matures, we're seeing the ultimate evolution of this trend. Section 4, the breakout role, the forward deployed engineer. So, what exactly is a forward deployed engineer, or FDE? Believe it or not, this role barely even existed as a discrete category back in 2025. But today, frontier labs like OpenAI, Anthropic, and Google are hiring them by the hundreds. Here's why. When a Fortune 500 company or a highly regulated biotech firm buys an enterprise AI solution, they don't just want an API key. No way. They contractually demand an on-site engineering specialist to actually integrate these massive models into their messy, highly secure legacy systems. That boots-on-the-ground expert is the FDE. They are the human bridge between the pristine lab and the very messy real world. Because of the immense value they bring, and honestly, the stress they absorb, FDEs are commanding astonishing salaries. We are talking total compensation packages routinely stabilizing between $350,000 and $550,000 for mid to senior talent. Enterprise buyers are literally insisting on these engineers as a non-negotiable core deliverable of their multi-million-dollar AI contracts. I mean, an FDE might be flying to a client site on a Tuesday to debug a secure server, living out of a suitcase while solving bleeding-edge integration problems. So naturally, that drives their market value right through the roof. So why is it so incredibly hard to fill these roles? Simple. The FDE requires a total unicorn skill set. Code meets customer. You need the deep technical chops to handle RAG pipelines, model fine-tuning, and context protocols, sure. But you have to combine that hardcore engineering with the soft skills, patience, and communication required to sit in a boardroom, face an anxious executive, and actually make the AI work within their unique corporate environment. It's the ultimate bridge between theoretical AI and business reality. You literally have to speak both GPU memory allocation and quarterly business objectives fluently.
So, what does this all mean for you? Let's move to our final section, number 5, the future of AI careers.
We're currently looking at a staggering 400% growth in demand for machine learning infrastructure roles. Think about that. This represents the entire tech industry waking up to a simple, unavoidable fact. Without a rock-solid infrastructure, the smartest machine learning models in the world simply cannot deliver real-world business value. The era of just researching, playing in sandboxes, and experimenting, that's ending. The grueling phase of production, security, and scale has officially begun. Because if an AI can't scale securely, it is completely useless to a modern enterprise.
But hey, here is the really fantastic news for many of you watching. If you are currently working in DevOps or as a site reliability engineer, you have a massive, massive head start. You already understand Linux, containers, complex networking, and how to scale resilient systems. If you can just take that foundational knowledge and adapt it, learn how to apply it to GPU clusters, vector retrieval, and managing probabilistic AI workloads at scale, you are perfectly positioned to step right into these highly lucrative infrastructure roles. Your skills haven't expired at all. They just need to be pointed in a new direction. So as we wrap up this explainer, I want to leave you with a provocative question to chew on regarding your own career trajectory. In this new digital economy, where AI is no longer just a novelty, but the absolute baseline, are you going to be the one trying to write the algorithm, or will you be the one building the vital, complex systems that actually keep its intelligence alive? Because make no mistake, the true durability of the AI age belongs to its infrastructure. Thanks for exploring this with me.